Night is honest. It doesn't pretend. It shows us the truth of distance and the truth of time. The stars we see are not forever. They are echoes, sparks from a fire that is already growing old. We stand in the brief, brilliant afternoon of the cosmos, a fleeting moment of warmth and light. And from this precious vantage point, we begin our journey where the light still gathers, knowing with a quiet certainty that it will thin. We ask the ultimate question, the one that waits at the end of everything. What remains when the last star dies? Before the final darkness, there is a long, drawn-out twilight. This twilight belongs to the red dwarfs. They are the quiet majority of the cosmos, the most common type of star in the universe. Small, cool, and incredibly patient, they are the masters of conservation, sipping their hydrogen fuel not for billions, but for trillions of years. While our own sun burns with a furious, brilliant intensity, these stars smolder with a deep, crimson calm. For ages beyond our current comprehension, they will be the only beacons in the sky. Planets that orbit them will be bathed in a perpetual, dusky red glow. Then one by one, across spans of time that defy imagination, they too will blush faintly and go out. The universe will grow noticeably darker with each extinguished ember. The stellar corpses left behind will inherit the kingdom. White dwarfs, the super-dense crystallized embers of sun-like stars, will continue to shine, but not from fusion. They radiate only their stored residual heat, like cosmic coals left over from a great fire. This process of cooling is agonizingly slow. For unimaginable spans, they will glow a soft, ghostly white, then yellow, then orange, fading for trillions upon trillions of years. Given time beyond memory, a quadrillion years or more, they will finally exhaust their thermal energy and become what we can only theorize, black dwarfs. Cold, dark, inert spheres of degenerate matter, utterly invisible, hypothetical ghosts in the range of 10 to the 15 through 10 to the 25 years. They are the final, silent tombstones of stars like our sun. Between these dying lights, the universe is a lonely place. It is populated by cosmic wanderers, brown dwarfs, the failed stars too small to ever ignite fusion, drift aimlessly, and countless rogue planets, ejected from their home systems during chaotic births, glide through the endless night. For these worlds, there is no sunrise, no seasons, no year to measure. There is only the slow, silent glide through an increasingly thin frost of starlight from the last fading embers of the cosmos. Alongside them are the neutron stars, the city-sized, hyperdense relics of massive stellar explosions. Spinning with incredible speed, they are cosmic lighthouses whose beams will also eventually fade to black. The degenerate era spreads, and its grip tightens. This is the age of stellar remnants. Dead systems rule the vast emptiness. Black dwarfs, cooling white dwarfs, silent neutron stars. The architecture of solar systems remains, but as frozen monuments. Asteroids and comets still wander in their ancient paths. Frozen worlds, their atmospheres crystallized onto their surfaces, continue to circle a silence where a sun once burned. The universe itself continues to expand, relentlessly. Space grows wider, colder, and time itself seems to slow down, as the interval between meaningful events stretches into near infinity. Yet, even now, the universe is not entirely dead. In the profound darkness, rare meetings can still ignite the sky. After trillions of years of solitary drifting, two remnants, perhaps two neutron stars or two white dwarfs, find each other in the void. Their gravitational dance spirals inward, ending in a sudden, violent crush of gravity. The result is a brief, furious bloom of light and energy, a kilonova, brighter than an entire galaxy, forging heavy elements in a final, spectacular act of cosmic alchemy. For a few brilliant moments, a corner of the universe is illuminated with impossible splendor. Then just as quickly the light fades, and night returns, deeper than before. On the largest scales, even the great island universes of galaxies begin to dissolve. The degenerate era gives way to something even darker. Galaxies, once vibrant whirlpools of light, begin to dim. Through a process called violent relaxation, their elegant spiral arms loosen and unspool into faint stellar streams. The gravitational glue that holds them together weakens. Stars are either flung away into the desolate intergalactic void, becoming lost orphans of the cosmos, or they begin a long, slow fall inward toward the monstrous object at the galactic core. Black holes eat and black holes merge, growing like immense, silent caverns in the fabric of space-time. We now enter the black hole era, for a length of time so vast it makes the age of stars seem like a heartbeat. These objects are the new masters of the universe. Everything that remains is now in their service. What is left of matter either orbits the dark in a state of permanent gravitational servitude, or it makes the final fatal misstep and crosses the event horizon. Gravity keeps the last ledger of the cosmos. The entries are brief, and they are final. The universe becomes a collection of gravitational islands, each ruled by a single, supermassive black hole, separated by voids so large that light could never hope to cross them. But even this absolute dominion does not last. Even black holes, the very definition of inescapable gravity, are not eternal. They leak, gently and imperceptibly. At the very edge of the event horizon, the quantum vacuum fizzes with pairs of virtual particles that pop into and out of existence. Occasionally, one particle falls in while the other escapes, carrying away a minuscule amount of the black hole's mass. This is Hawking radiation, a faint thermal glow at the edge of forever, a whisper that bleeds the giants of their power over absurd, almost nonsensical spans of time. The process is slowest for the largest. A stellar mass black hole might take 10 to the 67th years to evaporate. But the supermassive giants, with the mass of billions of suns, will hold on for much longer, perhaps 10 to the 100th years, a number we call a Google. After ages stacked upon ages, beyond any counting, a supermassive giant, the last great structure in the universe, finally loses its battle with quantum mechanics. In its final moments, the evaporation accelerates, and it exhales its final light, a soft, thin gamma glow, a final, lonely firework in the absolute void. And then, it is gone. With the black holes gone, what is left? Only a thin soup of particles in an unimaginably vast and cold universe. And here, the future splits into two possibilities. In the first, a fundamental theory of physics proves true. Protons decay. If so, then matter itself, the very substance of everything we have ever known, is unstable. The building blocks of atoms unravel. Over fantastical timescales, far longer than even the age of black holes, every last remnant of the physical world, the cold planets, the black dwarfs, the neutron stars, unthreads. They dissolve into a diffuse dust of radiation and lighter particles, leaving nothing solid behind. Even you and I, in our most basic constituent parts, are erased, or perhaps not. Perhaps protons are eternal. If they endure, then the black dwarfs, those cold, dead stars, have one last, strange act to play. In the crushing pressure of their interiors, over timescales that make proton decay look fast, quantum mechanics allows for a final miracle. Through a process called quantum tunneling, atomic nuclei can overcome their repulsion and fuse. Cold fusion. The black dwarfs slowly, painstakingly, convert their substance into the most stable element, iron. These hypothetical iron stars would be the last complex objects. They might even glow with rare, fleeting sparks from positron emission across impossible gulfs of time before settling into perfect, stable, eternal dark. And so, at last, the dark era arrives. The universe is now truly empty. No stars, no black holes, no warm planets, no possibility of structure. All that remains is a diffuse, ever-expanding sea of low-energy photons, the ghosts of evaporated black holes and decayed particles. Neutrinos, having barely interacted with anything for eons, slip by, witnesses to a cosmos that no longer exists. The thinnest whisper of electrons and positrons, scattered light-years apart, drift in the near-perfect vacuum. Time continues to pass, but it measures nothing. Entropy, the universe's fundamental tendency towards disorder, has finally and completely won. With no free energy left to create complexity, all meaningful physical processes wind down to a halt. The universe becomes a quiet, featureless sea of almost even temperature, just a fraction of a degree above absolute zero. It is smooth, still, and silent. This is the heat death of the universe. It is a state of maximum equilibrium. Nothing happens, and nothing ever will happen again. Is this truly the end? In the final silence, some theories whisper of a last, desperate hope. A quantum fizz. In the endless void, random quantum fluctuations could, theoretically, produce anything. A new Big Bang, a conscious mind, a Boltzmann brain, flickering into existence for a moment before dissolving back into chaos. Even Poincaré recurrences are suggested, the idea that if you wait long enough, an infinite amount of time, the particles in the universe will eventually return to a previous state, like our own. But these are deeply, deeply speculative. If they come in a darkness so complete that it has forgotten the very concept of light. Time stretches beyond names, beyond numbers. Trillions upon trillions of years, until the very concept of counting is a weathered stone from a forgotten civilization. The word forever ceases to be a measure of duration. Forever becomes a place, not a word, a destination. The final state of a universe that has run its course. The great cosmic story, from the first flash of creation to the last fading photon, is over. And yet, we are here. Now, we live in this bright, brief, improbable epoch. This sliver of cosmic time when the universe is not too hot, not too cold, not too empty. We are the universe made aware of itself. We make art, we tell stories, we build meaning, all while the lights still burn. We are the lucky ones, standing together under a flowing river of stars, privileged to witness the glory of a universe in its prime. The far future is not an answer, but a mirror. It doesn't tell us what will be, so much as it shows us what we have right now. It reflects our profound smallness in the face of cosmic time, and yet it also reflects our immense courage to ask these questions in the first place. To know our place is not to despair, but to appreciate the miracle of the present moment. Wonder is the light we generate ourselves. It is the light we carry into the dark. Keep looking.